This program discusses the construction and operation of the axle and brake assemblies on International's 510 and 515 payloaders. The photo shows a 510 with an art illustration overlaid to point out the various components of the drivetrain. Power is delivered from the engine to the torque converter transmission, then through the transmission output shaft to both the front and the rear axles. As shown in the illustration, the rear shaft assembly is very short. It consists of two universal joints at either end of a short coupling. This assembly connects the output yoke on the rear of the transmission to the input yoke on the rear axle differential assembly. The front drive shaft assembly consists of two shafts. One shaft goes from the transmission output shaft to a hanger bearing assembly mounted in a front frame member. A second shaft continues the power flow through the hanger bearing assembly to the front axle through the front differential assembly. The front drive assembly uses two shafts. Both photos show the telescoping shaft that goes from the output yoke on the front of the transmission to the slip yoke at the forward end of the shaft. The photo on the left shows the portion of the front shaft which is on the forward side of the hanger bearing assembly. This shaft continues the delivery of power from the telescoping shaft to the front axle differential assembly. The front differential is not shown, but the parking brake assembly, which is mounted on the back side of the differential assembly, is visible in the photo on the left. The photo was taken from underneath the machine, looking back from the front axle to the hanger bearing assembly. The hanger bearing assembly provides support and constant alignment for the rotating front drive shaft. The slip yoke and the universal joints at either end of the telescoping shaft allow power to be delivered to the front axle, whether the loader is moving in a straight line or is articulated. The axles used on the 510 and 515 are designed after International's worldwide axle. The photo shows the front drive shaft between the hanger bearing assembly and the front axle. The photo is from underneath the payloader looking forward. The shaft connects through a universal joint to the input yoke on the front axle differential assembly. The parking brake, which is mounted on the rear of the differential housing, is also visible in the photo. There is an obvious external difference between the front and the rear axle housings. As shown in the photo, the front axle housing has a mounting flange on either side so that it can be bolted directly to the lower side of the front frame. This photo shows the rear axle assembly. The photo is from above the axle, looking to the front of the machine. The engine has been removed for the photo. The rear axle is pivot mounted at the front and rear of the differential housing between a two-member cradle assembly. The rear cradle member is bolted to the frame as shown in the photo. The front cradle member is welded into the frame. This pivot mounting arrangement allows the rear axle to oscillate a total of 24 degrees when the vehicle is on uneven terrain. The rear axle housing is designed with a wedge-shaped boss on either side. This boss contacts the stop, mounted on the bottom of the frame, when the 12-degree oscillation limit is reached in either direction. Before going on further in the program, let's take a few minutes for review. The picture before you will help in answering the questions. Stop the tape while you are answering the questions. The answer to 1 is B, 2 shafts. The front axle has drive delivered to it by 2 drive shafts. The answer to number 2 is C. The hanger bearing assembly provides support and constant alignment for the front drive shaft. The answer to number 3 is A. Only the front axle is flange mounted to the frame. The answer to number 4 is A. The rear cradle member is bolted to the frame as shown in the photo. The answer to 5 is C. The rear axle of the 510, 515 oscillates a total of 24 degrees. A conventional differential is mounted in the center of each axle assembly. The differential consists of several components. The pinion drive gear delivers power from the drive shaft. It is shown at the right in the illustration. The pinion gear in turn meshes with the ring gear. Bolted to the ring gear is the differential carrier. The carrier contains 4 internal pinion gears and 2 beveled side gears. A thrust washer is located between the ring gear and the beveled side gear closest to it. The differential has 3 main functions. 1, it transfers torque from the drive shaft to the axle assembly at right angles. 2, it performs the first reduction of 3.6 to 1 in the double reduction axles. 3, the differential allows the drive wheel on one side to rotate at a speed different than the opposite wheel under certain conditions, such as when the vehicle is turning. When both wheels are free to rotate at the same speed, the internal pinion gears in the differential carrier do not rotate. Under these circumstances, both beveled side gears rotate at ring gear speed. But when one wheel is less free to turn, the internal pinion gears partially walk around the beveled side gear splined to the planetary drive shaft and deliver additional motion to the bevel gear for the opposite axle. Under these circumstances, the bevel gear on the freer axle rotates faster than the ring gear. The bevel gear on the less free axle rotates slower than the ring gear. A no-spin differential is available as an option for the front axle. The no-spin assembly is mounted in the differential carrier with trunnions fitting into the positions that would be occupied by the 4 pinion gear shafts in a conventional differential. The differential carrier is then bolted to the ring gear in the normal manner. The no-spin imparts drive to both side gears through a clutch and cam assembly. The side gears are splined internally to the planetary drive shafts. Springs keep both clutches engaged during straight-line driving so that the assembly acts as a solid unit with both side gears driving at ring gear speed. The illustration shows what takes place in the no-spin when a right turn is being made in a forward-moving vehicle. The clutch mechanism on the right remains fully engaged and drives the right wheel through the short arc of the turning radius. Since the left wheel must travel farther and faster than the right wheel in making a right turn, internal cams allow the driven member of the clutch on the left side to ramp up and override the spider, the driving member of the no-spin. On the conventional differential, the freer wheel gets the drive. The rotation of the internal pinions causes the wheel with the best traction to turn slower than the ring gear, while the wheel on the freer axle is made to turn faster than the ring gear. In the no-spin, there are no rotating pinions to alter the driving speed of the 2 axles. Neither wheel can turn slower than ring gear speed when power is delivered to the axle. Drive always remains with the wheel having the best traction footing. If one wheel is on soft ground or ice, positive drive at the opposite wheel carries both axles through at ring gear speed. With a conventional differential, all drive would go to the wheel with no traction, immobilizing the vehicle. If one wheel must move faster, as in a turn, the no-spin clutch disengages and allows that axle to move ahead of ring gear speed. The planetary assemblies are located on either side of the differential housing, on the inboard end of each axle assembly. In the center of the planetary assembly is the sun gear, which is seen in the illustration at the outer end of the planetary drive shaft. The sun gear, which is integral with the planetary drive shaft, is meshed with the pinion gears on the inside diameter of the planet carrier. On the outside diameter of the planet carrier, the pinion gears are meshed with the ring gear. As shown in the illustration, the ring gear is held stationary in the axle housing. The planetary drive shaft and sun gear accept drive from the beveled side gear of the differential assembly. The rotating sun gear causes the pinion gears to turn inside the planet carrier. The planet pinion gears turn against the ring gear, but since the ring gear is stationary, the rotation of the pinion gears sets the planet carrier in motion. This causes the axle shaft, to which the planet carrier is splined, to rotate and turn the wheel. Drive is transferred from the sun gear on the planetary drive shaft to the planet carrier on the axle shaft at a 5.4 reduction ratio. This reduction, when combined with the 3.6 differential reduction, gives a total axle reduction of 19.5 to 1. The conventional and no-spin differentials are alike in some ways and different in other ways. We are going to stop now to see if you can clearly state the similarities and differences. Stop the tape while you are answering the questions. The three functions of the differential are to transfer torque from the drive shaft to the axle assembly at right angles, to perform the first reduction of 3.6 to 1 in the double reduction axles, to allow one wheel to rotate at a different speed than the other under certain conditions, such as when the vehicle is turning. The answer to 2 is B. With the conventional differential, the wheel with the least traction receives the drive. For axles equipped with the no-spin, the answer is A. The wheel with the best traction receives the drive. The answer for number 4 is B. When an axle equipped with a no-spin differential is in a turn, one wheel rotates at the same speed as the ring gear, and the other wheel rotates faster. The answer for number 5 is A. The no-spin differential is available as an option on the front axle only. This illustration shows the components of the braking system used on the 510 and 515. A dual-chamber master cylinder supplies fluid to each axle independently. This system provides a special safety feature. If a pressure loss should occur at either the front or the rear wheels, only that one axle system is affected. The braking system on the other axle will be available to safely stop the machine. The brake assemblies are located inboard on either side of the differential assemblies. A bleeder valve is provided for each axle. The illustration shows 2 brake pedals. The one on the right simply applies the brakes. The one on the left applies the brakes and disengages the transmission as well. This photo shows the pressure-sensitive switch, which is positioned underneath the cover of the left brake pedal. When this pedal is used to stop the machine, the switch closes and activates a solenoid on the transmission, which places the transmission in neutral. When the vehicle is stopped with this pedal, full power is able to be used for the operation of the loader hydraulics. The right-hand brake pedal applies the brakes, but does not disconnect the transmission. An access door is provided on the floor in the operator's compartment for servicing the brake master cylinder. Fluid level must be checked every 500 hours or whenever loss of braking power is noticed. Both chambers should be within 1/2 inch to 3/8 of an inch from the top of the reservoir. If fluid is needed, IH Hytran must be used. System pressure is monitored at a junction block mounted on the inside of the front frame just ahead of the master cylinder. The photo is from the front of the vehicle, looking through the access cover opening. 2 sending switches are located on the valve. The brake warning switch is located in the center of the valve. This switch is activated if a pressure loss occurs in either the front or the rear brake system. The sending switch for the vehicle brake lights is seen on the right side of the pressure valve. This pressure-sensitive switch completes the circuit to the brake lights whenever either brake pedal is depressed. This illustration shows the brake warning switch and the brake light switch. The pin of the brake warning switch is in its normal position. The spring-loaded pin is resting on the two pistons positioned back to back. The pistons are centered by spring pressure. When the brakes are applied, the pistons remain centered because equal apply pressure is felt at the outer end of each piston. However, if either the front or the rear braking system develops a pressure loss, the pistons will move toward the lower pressure side. Under these circumstances, the spring-loaded pin in the brake warning switch will drop down, completing the circuit to a system failure light on the instrument panel. The pin does not reset automatically. The light remains on from the time the pressure loss first occurs until the system is repaired and the sending switch is repositioned. The switch must be removed from the valve when bleeding the system. It is replaced after system pressure is equalized and the pistons have returned to the center position. If the switch is not repositioned, the spring-loaded pin will become distorted by the force of the pistons as they try to center themselves in response to the condition of equalized pressure. An O-ring located behind the head of each piston keeps system fluid from escaping when the brake warning switch is removed. Each brake assembly consists of a piston, a brake friction disc, and a pair of backing plates. The backing plate between the piston and the friction disc is called the center ring. The plate between the friction disc and the planetary ring gear is called the outer ring. Drivetrain power flows through the planetary drive shaft, through the planet pinion gears, to the axle shaft. When the brake pedal is depressed, pressure is hydraulically applied behind the piston by the master cylinder through the fluid pressure port. This causes the piston to move out, causing the brake friction plate to be held between the two backing plates. Since the backing plates are not free to rotate, the friction disc and planetary drive shaft are quickly brought to a stop, halting axle motion. The photo shows the actual components of the brake assembly with the left rear axle housing removed. The brake assemblies used in the 510 and the 515 are the wet disc type. Oil contained in the axle and differential housing provides constant cooling for the rotating brake discs. As can be seen in the photo, the brake friction disc is splined to the planetary drive shaft. The center ring backing plate is visible in the differential housing just behind the friction disc. The fluid pressure port is visible on the side of the differential housing. The bleeder valves for both the left and the right axle brake assemblies are seen coming through the top cover of the differential. A low pressure of 300 psi used over the large area of the friction disc provides an immediate fade-resistant response. The brake assemblies require no adjustment. If one or both front brake assemblies need servicing, the front axle must be removed from the machine. If only one rear brake needs servicing, this can be done on the machine after removing the axle on the side affected. The photo on the left shows the piston being installed on the outside of the differential housing. A new O-ring has been installed on the differential bearing carrier and on the outside diameter of the brake piston. The photo on the right shows the piston being positioned with a special brake installation tool. Bolt the tool to the differential housing using 3 of the axle housing mounting holes. Then tighten the installing screws evenly until the piston completely bottoms. Each time brake pressure is applied, the O-rings roll slightly as the piston moves out. When pressure is released, the O-rings roll back to their initial contact position. When the piston is completely bottomed at installation, the 2 O-rings have established their deepest initial contact position possible. This O-ring positioning causes the piston to stay slightly away from the backing plate. This allows the friction disc to have free movement between the 2 backing plates except when pressure is applied. Each brake assembly should be tested before reinstalling the axle assembly in the vehicle. Attach a line to the fluid pressure port as shown in the photo. Open the bleeder valve and fill the cavity behind the piston with Hytran. Close the bleeder valve and pressurize the cavity to 200 psi. A lube gun with a pressure gauge attached in line can be used for this operation. A cutoff valve should be provided between the test gauge and the lube gun. Close the cutoff valve and hold the brake fluid cavity under pressure for approximately 5 minutes. If the pressure drops more than 50 psi, repeat the reconditioning procedure. After completing the reconditioning of the brake assembly and reinstalling the axle, bleed the system according to the special instructions contained in the service manual. IH Hytran must be used. This axle pressure test can also be used to locate the source of a problem before the axle is removed. If the system failure light goes on, check the lines and hoses for external leakage. If there is no external leakage, internal leakage is indicated at one of the 4 brake assemblies. Uncover the master cylinder and observe which end of the reservoir is low on fluid. The front chamber supplies the front axle system. The rear chamber supplies the rear axle system. If the rear axle chamber is low, the test can be used to determine whether the right or the left brake is the cause of the pressure loss. Only the axle housing on the failed side needs to be removed from the vehicle for repair. If the pressure loss is in the front axle system, the complete axle assembly must be removed from the vehicle. But this pressure test will indicate which side of the axle assembly needs to be opened for repair after the axle has been removed. The parking brake is a 10-inch drum-type brake. It is mounted on the rear of the front axle as shown in the photo on the right. The parking brake actuating lever is shown in the photo on the left. It is located in the operator's compartment just to the right of the loader levers. When the brake is applied, the shoes lock the motion of the differential pinion drive shaft to the pinion cage. This prevents movement of both the front and the rear drive shafts since they are connected through the transmission output shaft. The parking brake will hold the 510 on a grade of 22 degrees. It will hold the 515 on a grade of 20 degrees. A clevis is provided on the end of the control cable if adjustment of the brake is necessary. As a safety precaution, the parking brake should be engaged whenever the operator leaves the vehicle. A safety lock is also provided for the loader controls. When it is applied, the loader levers cannot be moved from the hold position. Before going on further in the program, we are going to stop for a review on the braking system used on the 510 and 515 payloaders. Stop the tape while you are answering the questions. Number 1 is B. Pressure loss in one brake assembly will affect braking only on one axle. The answer to number 2 is C. The left brake pedal is used to place the transmission in neutral at the same time the vehicle brakes are applied. The answer for 3 is B. The brake warning switch should be removed before bleeding the brake system. It should not be replaced until the bleeding process is completed. The answer for 4 is D, all of the above. When reinstalling the piston, new O-rings must be used and the piston must be completely bottomed. The answer to number 5 is B. The brake assembly pressure test should be used before servicing an axle that has lost braking power to determine which brake assembly has failed. A is not a correct answer. To determine which axle is affected, a level check of the master cylinder must be performed. C is not correct either. A repaired assembly should be pressure checked, but it should be done before reinstalling the axle into the machine. This program continues on tape 2.